welcome everybody to this webinar. Okay, first, the summary of what we're going to speak, what we're going to present today. At first, I will give you a brief introduction of the PD Pro new software, the idea behind the software. Then we will see what are the compatible instruments that we can use with PD Pro. We can also see which asset can we test with PD Pro. Then we'll go into the database functionalities. I will show you briefly the advantages of the DB functions. And then we will see, since we received so many questions in the past webinar, few slides about the time frequency map, the Techimp patented technology. I can also inform you that we will have a webinar just for TF map later on this month or in July. In the end, we also will see the acquisition modes we can use with the PD Pro, then a few examples of functionalities and a question and answer session. The presentation will be sent to all of you in a PDF format, and there is also some files that you can download to have a more clear idea of what PD Pro can do. So let's start. Since we are talking about testing, the idea that we have developed in the years is that the software for PD testing should make asset managers' life easier. We should have a good data management architecture. We should follow some standardized test procedures. We should have homogeneous data for different instruments and different years of the same years of testing. And also, we should be able to compare all the results and trend the result over the time. The final idea was to have one platform for the different users, those are involved in the condition-based maintenance. The main groups, those can be part of the process in asset managers, are the testing teams. Those will take care to acquire data. The data management, so the history of the asset, how the asset has been developed during the years, what were the intervention made, to the maintenance made, and in the end, the analysis of the data and the decision makers. All these different sides of the problem can be put together in the PD Pro, and we have information and knowledge entering the system, and we should have decision and risk reduction as an output of the system. First, the PD Pro can have different users. We have one license, but each license can have different users. So we can imagine about testing team users, engineers user, and in the end, asset manager use. It's very easy to create new users for the PD Pro. We just need an email, and we just need to have the licensee administration of the software able to create such different users. All of them will have its own password, but it will be possible to exchange data between these different users. Let's see now what is the compatibility of the PD Pro. First of all, about the instruments. The PD Pro will be the center of all Techimp instruments from now on. It will be possible to work with Aquila and MicroAquila. Those are designed to perform site testing, online site testing especially. It will be also able to include data from permanent monitoring systems. So we can extract the data from an existing permanent monitoring system and include it in the PD Pro database. We can also use the same software to work with the laboratory testing instrument. In our case, the PD-Base2, that is EAC 60270 compliant and can be used for pulse width modulation testing and type test of insulation. Also, the new medium voltage asset monitoring Falcon can be used with PD Pro as a data viewer. We are able to export the data from the Falcon, that is a web-based instrument self-standing, and we can include it in the PD Pro and study it with the PD Pro tools. Last, the classic Techimp instrument, the PD check, the first generation of on-site PD testing instrument, is still compatible with the PD Pro. We can acquire data and analyze data with the same instrument. In the future, all the next generation testing equipment will be compliant with PD Pro, and we can take advantage of PD Pro functionalities. We also have compatible data. Here on the left, I have listed the main Techimp software from the past: the PD-based standard and acquisition software, PD check control, and other acquisition software for the PD check family, and the PD processing, that is the universal software for analysis of PD data. Also the monitoring system, permanent monitoring system, the older TIMS and the newer TSCADA are software. Those are all compatible with PD Pro. PD Pro is able to include all the existing data in the new database, and we can manage it, the old data, just like the new, taking advantage of all the new functionalities of the software. Last but not least, another point of view on the PD Pro compatibility. We can use PD Pro in all the different moments of the life of an asset. We can have the data from the quality control. We can have the data from the commissioning test or from online spot testing performed with the PD check family equipment. And we can also include in the PD Pro the data from the permanent monitoring. It's an all-in-one software that is able to acquire all the different data. Those can be created during the lifetime of an asset. And let's start to look a little bit into the database functionalities. This is a brief summary of what we're going to say about the PD Pro database. We will have an overview. We will see how to create a new registry, how to query existing registry, how to query old acquisition, how to import data, and how to query test plans. The database will be, let's say, useful for, at first, create a census of the critical assets. By creating new registry, we can generate the identification for the asset we're going to test, the asset we want to test, and we can link all the information there. So we have basically a map inside our DB of what we can test and why and what we want to test. We create basically an asset book. We can query the registry, we can recall the existing ID created with the creating registry function, and we can recall it to or process data or to perform new acquisitions. Those will be included in the DB as well. Then we can use it as a browser. Once we have, let's say, created the DB, we have all the function to manage the existing data. We can, for example, look for the data related to a certain voltage level of cable, to a certain kind of motor, and we can see all the acquisitions related to these filters. It can be also included with the PD identification tool. If we identify the browser as some certain kind of PD, depending on the asset, we can save this identification and recall it as a browser function. In the end, we can also create test plans. Those are standard test plans, can be implemented once in a while and launched at every test to have, let's say, a roadmap to follow and standardize all the test procedures. Let's see the first function, the new registry creation. Basically, this is the very first step we can do. We will put the details about what we're going to test. We can, for example, create a cable function like this one in the picture. We have to put the customer name, the circuit name, the location, the rated voltage, serial numbers, and manufacturer. All these functions will be saved and can be browsed with the DB. Once we have created this registry, it's like a folder. Inside of that, we can save all the detection points related to the asset. Normally, we will have a three-phase system, and we can have several detection points. I mean, if we have, for example, a high voltage cable that is one of our biggest activities, we will have as many detection points as the joint base of cable normally. In generators and motors, we will have maybe just 1 or 2 detection points, depending on the installed sensors. And now we have a short video to show you how easy it is to create a new registry and to create the identification of the asset. Some of these fields are mandatory because we want the database to be able to find for these fields in the whole data storage. So we have to put this information in order to be browsed. With the filters, we will have some searching capabilities like equal to name or name that contains this particular word. It will be just an advantage to have a more powerful DB function later on. In this case, I've selected a generator. I will select three-phase system. Phase name can be renamed. For example, I put here red, yellow, and blue, very classic. And if I'm not wrong, in this video, I've also implemented not just one detection point, but I've put, for example, existing generator with 2 kits of sensor installed. Those are normally called the machine and systems. And we can select also the voltage type and the machine typology. Oops, typo. Here we can put basically a brief description of the machine. When everything is saved, we will have a created registry able to receive data. Now we'll see the query registry function. So we can retrieve all the existing registries from the query registry function. We can select it one by one. If you see, we have some columns like ID of the registry, that is a number, customer name, circuit name, location, or apparatus serial number. We can also browse and filter the existing queries. As I told you, we can select a registry, we can select the customer name, we can select which type of asset we want to see, or also more filters. In the more filters, we have a lot of possible, let's say, browsing functionalities. We can go in different identification of PD, we can go in different manufacturer name, we can go under different cable lengths, for example, if I'm not wrong. All of the information, those we have entered in the acquisition process and in the data import process will be browsed by the query registry. The other function is the data import. As I told you, we can have, for example, a very big DB with the old school softwares, but we don't want for sure to lose the data because we know that in partial discharge testing, the comparison and the trending of the data is very important. So we can import all the data into the PD Pro. When we import the data, we will also be asked which phase is the data related to, what was the detection point, also which sensor have we used, what was the synchronization sensor source, and what was the PD test typology. This is useful because such information were not part of the PD data previously. We maybe have a TXT file in the same folder saying the test was performed with capacitive coupler or with HFCT, and there is no clear, let's say, field for that information to be saved and stored for the future. It's, let's say, a new approach that also gives you the idea of not just to save the PD data, but to save also the kind of tests we've made and all the details. Those can be useful during the analysis and trending. Query acquisition, basically we can recall the single acquisition we've made, and then we have some functions to to be used together with a single acquisition. If you can see these 4 rounded buttons on the bottom right of the graphs, we can do the processing, we can copy the data, we can export the data, so we can create data with this single acquisition, or we can delete it. Last, the query test plan. There is the chance to save in the DB not just the PD data, but also the test plans. That will be a route to follow when testing. It's very popular, for example, for the laboratory testing in ESE 60270 standards. We can create a series of assets, a series of motors, of transformers, or whatever, and they have to be tested all in the same way with some voltage steps for a certain amount of time. We can create, or our manager can create, the test plan for us, and the operators in front of the PD Pro will just run this test plan to make sure the standardization of the test is maintained. Now, we can talk about PD Pro and assets, because we have seen the compatibility of the PD Pro just referred to Techimp family instruments right now. Actually, it is embedded, so we know that right now PD Pro can work with Micro Aquila, Aquila, PD Base 2, Falcon, PD Scope, and so on. But this is not referred to asset. Like, is it possible with PD Pro to test a generator? Yes, it is, obviously. There are several things that we can do the generator. Once we have the proper sensor, every asset of the one I'm going to, let's say, explain in a few minutes, have their own spot in the DB and can be easily managed with the PD Pro. In case of rotating machine, we will select this registry, and we will have to, let's say, define in the registry which kind of sensor we're going to use. Are we going to use 1 nanofarad capacitive coupler, 80 picofarad capacitive coupler? So together with the PD acquisition, we will also include the information about the test and the asset. Another asset we can test, for example, are switchgears, air insulated switchgears. We can test them with TV, with HFCT. All this information can be included in the data itself, will be always with the data, like a permanent fingerprint on that one. And the same, we can obviously use the PD Pro for testing cables. Normally in this case, for example, we can differentiate between high frequency current transformer, or we have other sensor like flexible magnetic coupler. We can have embedded sensor in the high voltage cable. We can have HFCT around the volt cable. So it will be interesting also to store this data into the PD Pro and create our own DB with all the different testing solutions. Same thing can be done with transformers. We can have different type adapters, and a very interesting thing that we will see later on is that we can create a DB not just about the transformers, but also about the bushing type we are testing. So we will be able to browse the bushing type. Maybe we have a population of 15 transformers. They all have the same manufacturer, but we have seen that there is different data resulting from one manufacturer of bushing respect to another, and this information can be stored and made more available on the DB. Last but not least, the GIS, Gas Insulated Switchgears. We will be able to compare the data with the external sensor, with internal sensors, and we will see that in this case, it will be very interesting, in my opinion, for us also to compare the result with different manufacturer of sensor that we can see. So let's start with the high voltage and medium voltage cable. The data will be organized very easily. We can have or data related to one phase. So when we have, for example, 3 core cables, we will have all the phases in just one detection point. Or we can have the different phasing, red, yellow, and blue. So if we can perform PD test phase by phase, we can select all these 3 phases. Then in the detection point choice, we can instruct the system how many detection points we are going to test. In this case, I was thinking about a high voltage cable with the 4 joint each phase and 2 termination, 1 outdoor sealing end and 1 GIS sealing end. All this information will be saved in the registry and can be reused when testing and when analyzing. Once we save, all this information will be part of the DB. Again, in the GIS insulating system, we can have or a 3-phase bus duct or a single-phase bus duct. We can identify for each bay, for example, a certain number of detection points. And normally, these detection points are identified already, like we are testing next to the cable income, next to the circuit breaker, next to the earthing switch, or next to the bus bar. In case of embedded sensor, we can just recall the names present in the labels of the GIS to have a very clear map of what we are testing and where. For the rotating machine, in this case, as I put on the video before, I was thinking that the only bigger variation that we can have is between the single kit or the double kit of the sensor installed in the rotating machine, and we can put a small comment of what we are testing. Is it an air-cooled turbo gas? Is it an Hydro 1 generator? And so on. Please note that, for example, one point that is quite important is that at this stage we will identify just the detection point. But when we are saving the data, another pop-up window will come asking to us what kind of sensor are we using? Is it a capacitive coupler? Is it HFCT? Is it a new sensor not present in the list that you want to include? And also, what is the synchronization source? This can be useful, for example, if we only have 1 people taking care of partial discharge in our company, but we need many people testing all the plant or all the plants. Those can be also far from each other. In this case, the only expert guy that is able to analyze the data will have all the information those are normally required to do a proper analysis, the kind of sensor, the synchronization source, and he can, let's say, close many of the doubts that he can have during the analysis of PD. Again, in the switchgears, it's similar to the GIS platform. We will have basically the single panels to list, and we will say, okay, we're testing with this, with TV, with HFCT on the ground lead, and we will make a map of the switchgear. In this case, I put, for example, income feeder, motor A, motor B, distribution trefoil, auxiliary A, and spare. Last but not least, the transformers. In this case, we can also, let's say, put some information about not just the detection point, but also the bushing type typology that we are testing. We can have 1 or 2 in case we are testing 6 bushings transformers, and we can insert this. We can put this information into the database and retrieve it later on during the analysis and when we want to compare data.